This session, we are going to explore prompting techniques. We will look into different techniques, how to get consistent and accurate results, and how to enhance the model capabilities. So we should be able to integrate that into our business applications. So by default, when model come, it has some inherent limitations. Model is trained up to a certain date, and after that, it is put into the production that. Any event happened after that date, the cutoff date, this model has no idea because it is not updated regularly. If you see, let's say, for example, GPT-4, March 2023, that was the release date. And after that, any event happened, if you try to go and ask the question, this model will not be able to answer the question there. If you look into GPT-5, that's the most recent one. It came in May 2025. But again, limitation is still there. Try to ask some question after this particular date, and model will have no idea about that incident. This limitation is not only for OpenAI. If you go and look into Anthropic's or Facebook model or Llama, all of those models, they also have some sort of inherent limitations related to the cutoff date. There is another limitation. These models are trained based on the generic data, which is publicly available. If you try to ask any questions which is specific to your organization or private company data, this model will not be able to give you accurate information. There might be some answers. They are guesswork or some sort of boilerplate answers, but they will not be accurate. Similarly, there is another limitation if you are trying to ask some information which is continuously changing. Like, for example, if you want to know the weather information, if you try to go and ask, give me a city name and tell me the weather there, the model cannot tell you that one. The same is the case if you want to know the stock prices for any particular ticker, the model cannot tell you that. So another flavor of that is if you try to ask these questions from different model, the results would be inconsistent, and even model to model it will vary. And even for the same model, if you try to ask these questions in different settings, you will be getting some different answers different time there. So these are the known limitations related to the model. First thing is awareness. We should know all these limitations as a developer and end users. We should know how these models are trained. So we need to be careful about the decision making. And the second thing is we are going to look into different techniques. How can we overcome, or maybe we can enhance these capabilities to find the workaround solution for that one. We are going to look into 4 different techniques. First one is the multi-shot. We will provide different patterns and examples and then ask the questions. The second one is we are going to do the tool/API integration and then ask different questions. In a way, we will be helping the model by providing additional services. So tell the model if you need, you can consume these services to get the answers. So in a way, the overall model capabilities will be increased here. Third one is we are going to look into context. We will provide additional information and then ask the question. And the fourth one is sometime model don't know the answer and still model try to do the guesswork and sometimes try to make up things which does not even real or does not even exist there. It's called hallucination. We will also look into the safety technique and what kind of additional information we can give it to the model to prevent these kind of issues there. So if you see the first one, multi-shot, we are going to provide some examples. We will come up with some sort of structure, define different labels, give some example, and then ask the question. So that is the first one. The second one is we will look into the tools. We'll provide some additional APIs and then make the call. I have working examples ready, so I won't spend much time on the slide. I'll directly go to the working demos there. We will provide some additional context and compare the good prompt versus bad prompt, and then see the different output from the OpenAI there. And the fourth one is hallucination. We will try to look into different strategies, especially the refusal policy, where we are going to tell the model, hey, don't answer the question if you don't know. Do not try to do the guesswork there. And similarly, we'll also try to do the validation and enforce some sort of acceptance criteria to provide answer, which could be cross-check or once we get the information from the model there. I have uploaded this example into a repository. If you go to the repo, you will see a new directory there, prompt demos, and underneath 4 different files has been uploaded. You clone it in your local machine, and then we'll try to run this one by one. All right, I have loaded the project into PyCharm. Before we go into the code, all these examples, they are going to use the the key for OpenAI, and I don't want to hard code that into the actual code because we are going to put that into the Git. So what I have done is I've created the file environment.env and put the key over there, and I won't be checking in this into the Git. One good thing about this idea is if you go to the settings under that plugins, go to the marketplace, and if you try to search for env file, there is a plugin for that. And through this plugin, it is going to recognize the .env file. And at runtime configuration, we will be able to connect this with this environment where it will read the environment variable, and we should be able to run these applications without hard coding the keys inside the code. I have created 4 different examples. Let's look into these one by one. First one is tool integration demo. Let's see here. So I'm using OpenAI, and here if you see I'm not providing any parameter, so it assumes this information will be coming through environment variable. So if you right click and try to run this application, it will complain about the key not found because it's looking into the environment variable right here, open API key environment variable not found there. So what we need to do is you right click, and instead of running, go to run configurations. Under run configuration, if you see there's an option there, path to .env file. You click on that one, and the environment.env that has the key. I'm going to attach it here so that you know we should be able to run this, and at runtime it will find the OpenAI key there. All right, so I have created 2 methods. One of that is get weather. You provide the city name, and it is going to use one of the free REST service to get the data. This is number one. And there is another one, it's called get stock prices. You give the symbol, and it is going to make a live REST call to get the current price and then return it. Now, the purpose is not to explain this code. This is an example. I want to explain how you can leverage your existing APIs or those kind of stuff into your own organization and extend the capabilities there. So the bottom line is we have 2 methods, get weather, and the second method is get stock prices. Now we need to register these methods. If I go down there, so we have created a collection called tools, and here all the artifacts need to be registered. Type is equal to function, provide the name of the function, and then the description, brief description here, and then the signature need to be provided there. What are the type and those kind of stuff there. So this is first. The second one is very similar to that, get stock prices. Again, the structure is there, and then we are going to provide this information to the system prompt when we make this call at runtime. All right, so if I go down, all right, so this is the main method. Under main method, I have written 2 queries. What is the weather in New York? This is the first question, and the second one is how is the Tesla stock doing there? So the keyword here is weather and New York, and in the second one, Tesla and stock. These are the buzzwords there. And in a loop, I'm trying to invoke in a loop for all these queries. So if you go here, chat with tools, this is the actual object created for OpenAI. The model is GPT-4o Mini. This is the cheapest model as of today. I initially set up this example with 3.5, but that model is not there. So today I upgraded to 4.0 Mini. And then in the content, we are providing the user messages, the 2 questions we ask. The role is going to be user, and there is one additional parameter. Tools is equal to tools. This is the way we register these tools with the model. So model should know you are allowed to run these routines if stated there. So that's about it. If we are going to run this, let me try to run this guy. And at runtime, let's see the behavior, if it's able to get this information live or not. All right, it's trying to get the weather for New York. Yep, it got it. So the city is New York, temperature is equal to 19 degrees centigrade, description is sunny, and humidity is 71 degrees. And same is the case for if you see the how is the stock doing for Tesla. Right now, Tesla is trading at $330.36 there. Right, that's how the integration work and model capabilities has been increased. If you do not register and directly try to go and ask GPT or Claude or any model, they will not be able to answer these questions here. So in this way, any web services or any REST services, those kind of stuff, you can come here, register it, and that way model will be able to recognize them at runtime, and your overall business domain has been increased in terms of knowledge base of the model. That was the first one, and we are going to look into two more examples. The second one is multi-shot. I have tried to create a bad example, then good example, try to improve it so that you should be able to do the quick comparison. For example, if you see here in the multi-shot prompt, the first is the poor prompt example. Poor prompt here is without giving any additional information, all we are saying is classify the sentiment of this text as a positive, negative, or neutral. And then we are saying the delivery was delayed because the customer service team handled it well. Not only the model, if you give this kind of information to a human and ask to do this kind of stuff, because this is a confusing statement and somewhat inconsistent, even humans cannot do that one. But if you see now, this is a bad example. We try to improve in the second good example. So this is what the structure we came with. There are provide all the possible combination examples and then ask the question. And it will also give us a pattern, and then model will be able to understand exactly what we are asking. So for example, you see, I absolutely love this product. It works perfectly. And the sentiment is positive. Second one is, this is the worst purchase I ever made. And then we are saying the sentiment is negative. All right. The third one is the product arrived on time and matches the description. And then we are saying sentiment is neutral. All right. We got positive, negative, and neutral. Now we are going to ask the question. The delivery was delayed because the customer service team handled it well. Then ask the question. And now, and then we are giving some test cases, multiple. We are giving 4 different questions and then trying to ask this prompt again and again, different answers. And then it will be able to give you the answer. That's about it. It was very high level overview to show you multi-shot prompt by giving additional information as an examples. This would help the model to get the accurate information there, and it will be consistent as well. Third example is we are going to look into the context prompts. So if you see one more time, I put together one example of the poor prompt and then we'll try to improve it. So the question is, plan a trip for a family. That's the question. If you ask this question from any model, model will bring something as an answer, but not necessarily how precise or accurate or consistent that information is, and how well that serve your needs. All those questions, that's a TBD, and it is going to change every single time you will ask the question. On the other hand, if you ask this question in a different way with a very predefined question, let's say, for example, here, right? You say, you are a travel planner. This is a good example. You are a travel planner. Help me a weekend trip for family of 4, 2 adults, 2 kids, age 8 and 12. From New York City, maximum 3-hour drive, and our budget is 1200. Love outdoor activities, needs a family friendly option. And at the end, we are also giving the acceptance criteria. When you give the answer, it should fit these criteria there. So provide exactly 3 destinations with name and brief description, top 2 activities for families, accommodation suggestions, and estimated cost. There is a big difference between these 2 questions. If you ask this question versus this a lot of context you provide. It's very easy for the model to give you accurate information. So in a way, you need to help the model to get the help from the model. That's the thing. And it is not a model, even if you compare it with even with dealing with humans, if you try to ask this kind of question, which is missing a lot of key details there, that is one way. On the other hand, if you provide all the relevant detail, the answers will be very helpful and it will serve your needs better. That was the third technique, and now we are going to briefly look into the fourth technique, that is the hallucination. Here, what we are going to look into is there are so one more time. If you ask a question from the model and model don't know the answer, sometime it make up thing which are sometimes not even real and try to answer the questions. I tested this while writing another example. I was just playing with the model and asked some API Java APIs and some of the method names, and I put some comment there, that the system is going out of the memory, heap is going out of the memory while running this method. Give me the techniques to do the optimization. And this model, it went so crazy and it started giving me answers for the method which does not even exist in that API there. That was not one time. Then I start asking some broader level, some dumb question, and all of them were fictitious. And surprisingly, every single time model was able to give some answers there. How to avoid this kind of stuff? We need to give some additional information, additional instructions to the model so that it should fulfill and do not try to do the guesswork there. We can say once again here. All right. So we can say as a system prompt, this is a system instruction. Always provide a reliable source, URL, book, or paper. If no source, say no reliable source available there. And then ask this question: who discovered Atlantis? So Atlantis, this is not a real country. This is it's there, I think, in one of the book. This name is being used. And if you go and ask this question from multiple models, they will tell you some name there which is not real. So that is one. Same is the case. This is very important. It's called refusal policy. You can say the model, you must never make up facts. If you don't know answer, say I don't know. This is the instruction for the model. And now, after this instruction, if you go and ask a question, what is the population of Mars in 2025? Clearly, it will tell you that I don't know. Or maybe it's like, it's not going to give you some makeup information, which is to just to say something. The fourth one is the validation layer. We can add some additional thing. We can say, like, for example, answer with the number only if you are certain. If not, respond unknown. And then we are asking the question, how many moons does Earth have? All right, that's a very good example actually. So this is one additional validation layer. Based on that, we are asking model to give accurate information which fit this criteria there. So these are the four ways we look into different techniques where we are helping the model by extending its capabilities so that when we ask the prompt, a model should be able to give us accurate, consistent, and reliable information in the same setting. If you ask the question again and again, that's one way. And so in all these techniques, up to certain extent, we are able to extend the capabilities. But in big picture and in production ready system, these techniques are not good enough. In the next session, we are going to look into RAG that will further enhance the capabilities, and we'll try to bring large knowledge base from your organization into the model, and then try to create some examples where we'll be able to get this information, connect your model data with your organization level data or a particular domain, and then try to get the answers from there. We'll explore that into the next video. Thank you very much.